the bottom of page 3 and the top of page 4 in your notes, you're supposed to fill all that out. The video has been posted that you're supposed to watch, so answer those questions. It's probably something you know about, but just make sure that you're able to explain it. Remember, the difference between a 2 and a 3 is explanation on the exam. So, this kind of relates a little bit to what we did at our lab on Friday. A little bit. So, remember, when you have a solution, you have two parts, the solute and the solvent. One useful property is electrical conductivity. So we have strong electrolytes, weak electrolytes, and non-electrolytes. Very strong conduct very well at conducting electric current. Weak only conducts a small amount. And then non-electrolytes don't conduct anything. So in this picture, A is strong, B is weak. Notice how the light bulb is a little bit glowing. And then C, no ions, so no light bulb whatsoever. So in our lab that we did on Friday, you guys were just measuring with the voltmeter what the voltage was, but you could, instead of using the voltmeter, you could connect a light bulb to that and then see the light bulb light up, and that would be another way. It just wouldn't be quantified to see how much electric current is being passed between our cells. Svante Arrhenius was the first scientist to determine the basis for conductivity properties of solutions. He came to believe that the conductivity of solutions came from the presence of ions. So he predicted that the ability of a solution to conduct electricity depends on the number of ions present, which is still believed to this day. So just a little refresher about strong electrolytes. They're completely ionized, so they dissolve completely in water, meaning they break apart. Soluble salts are ionic compounds that break up into their cations and anions, and they become hydrated, which means they get surrounded by water molecules. You're going to see that in the video you will watch. Okay. Arrhenius also studied acids and bases. So acids dissolved in water. He proposed that an acid is a substance that produces hydrogen ions, or also known as protons, when it's dissolved in water. That professor is kind of talking about this a little bit. Today, we know the acids that he was talking about as strong acids. So there are 7 strong acids that he studied, and we know them, well, 7 acids that he studied, and we know them as strong acids today because strong acids are strong electrolytes. Connection there. Sulfuric, nitric, and hydrochloric acids are some of the examples of the 7 strong acids. The third class of important strong electrolytes are strong bases. These are soluble ionic compounds that contain the hydroxide ion. So common strong bases are sodium hydroxide and potassium hydroxide. Most common, I would say, is sodium hydroxide. We use that the most. But the hydroxide will separate from the cation and move independently throughout the solvent. And what it does is it grabs onto those protons from the water, and it makes the pH go higher. Weak electrolytes only ionize a little to a small degree. The most common are weak acids and bases. Vinegar was one of our things that we could make our competition cell out of, and that contains acetic acid, which is a weak acid, because only 1% of the molecules dissociate. So did everybody try vinegar on Friday?
Yep.
I don't remember right now. Did vinegar work well, or did it not work well when you were testing to figure out the highest voltage?
It worked well.
It worked well. Did anybody add something to the vinegar, or no? Did you put the vinegar in the anode or the cathode? I don't remember either.
The anode, I think.
In the anode?
Yeah.
I think, yeah, wasn't it with zinc? Most people put it with zinc, and they didn't put it with copper.
Right.
So maybe that had something to do with it, with putting it with the anode was better than putting it with the cathode. I don't know, but it was a weak acid.
Is it a coincidence that they beat us by 0.02? Like,
I don't know, that could remind me of England.
Okay, but Courtney and I did the same experiment as like the person who got like 1.02.
They got,
And we got
0.8.
Who knows? You guys, it wasn't a contest for reals. It's okay.
They definitely seemed like they were like
They were like,
very good lion.
They just wanted to win.
She's like, I'm gonna
We were stronger in numbers, so then they just wanted to win. The most common weak base is ammonia, which is NH3. That's something that I just assume you know, but a lot of times you forget about. So ammonia is NH3. Ammonium is the NH4 plus
I
1.
don't like how they're basically the same.
Yeah, it's just the difference of a proton. When ammonia dissolves in water, it creates ammonium ions and hydroxide ions. So sometimes, because it makes the ammonium and the hydroxide, instead of calling it ammonia, like when I order it from the store, the chemical store, sometimes it comes as ammonium hydroxide instead. But it's still ammonia in water. So that's just what happens, is it creates those ions when it does dissolve. Because it loses the proton, which goes to the water. Just like the acetic acid, ammonia only has about 1% of its molecules dissociate. So weak means it dissociates less. Non-electrolytes do not produce any ions. So some examples of these are table sugar and ethanol. So these both do still dissolve in water. They just don't create any charges. They don't have ions, so there's no charge, so no conductivity kind of thing. Okay, so example 17. M plus is an unknown metal cation with a +1 charge. A student dissolves the chloride of the unknown metal, which could be said MCl because M has a +1 charge, is in enough water to make 100 milliliters of the solution. The student then mixes the solution with excess silver nitrate solution, causing the silver chloride to precipitate. The student collects the precipitate by filtration, dries it, and records the mass of the data shown below. The molar mass is such. You don't need to know most of that. What you need to know is which of the following diagrams best represents the silver nitrate solution before the reaction occurs. And note, the water molecules are represented by that symbol. So, just a refresher, which part of the water molecule are the H is? The little ones are the H, and the big one is the O. And which side is slightly negative and which side is slightly positive? So what's the number? The O is the negative, yep, and then the H's are slightly positive. Okay, so that, remembering that about water is going to help us pick which is the correct representation of silver nitrate solution. Okay, so we have four choices. Is D going to be the choice? Is silver nitrate going to stay together? No. No. Nitrate ions are very, very soluble. Anytime you have an NO3, it's always going to be AQ, which means breaks apart. So that tells us D is not a good answer. Okay. The rest, A, B, and C, have them split apart, and they have waters going around them, but only one of them is the correct choice. Which one's the correct choice? A? Why? Yeah, because the oxygens are attracted to the silver and the hydrogens are attracted to the nitrate. B is wrong because the waters are surrounding, but they're not all the same in the direction that they surround. And then C is wrong because the oxygens around the NO3 are not supposed to attract to the NO3. Okay? So that would be a pretty simple question that you could get read in the AP exam, right?
Yeah. Really
Or on your test. It's going to happen on
Oh.
November 13th.
That's
Yeah,
the day after
maybe.
my birthday.
I can't remember.
I think it's not my birthday.
It used to be
smart
before we
sometimes.
changed it that one day.
Yeah. Questions?